for me to hand stuff back, then we'll get to it. But if there's not, there's not. Okay. Just know that everything is in the grade book. Everything is up to date. So if you go on Infinite Campus and check your grade, that's what it is right now. You can see your test scores and your homework scores and all your scores for that. But we'll get to them at some point. Okay. We did tweak the plan for this week, just so you are aware. Okay. Originally, the formative was going to be on Thursday. Now we are going to have the formative tomorrow. Okay? Alright? So the plan is we're going to talk about roots today. Tomorrow we'll do probably a power example and a roots example, and then we'll take the formative. 6 questions. I think I said leave everything in trig form, so it's actually a pretty quick and easy formative, which gives us time to do some of that stuff. Then on Thursday, we're going to take part 2 of the EMPT. Really, it's not part 2. You're going to take the exact same EMPT test that you took in the fall. You're just going to take it again so that we have that data, and then we can update we have SLO for us. What was that? That's the thing in the Chromebook. Yep. So Thursday, you need your Chromebook. You need to charge Chromebook on Thursday, or bring a charger on Thursday. Okay. All right. Test is still next week, Wednesday. Okay. Week from tomorrow, and your final is still 2 weeks from tomorrow. Okay. So test is still Wednesday of next week. Final is still Wednesday, Thursday of the following. Okay. So we just tweaked all around a little bit this week. So we're good to go. Any questions on it? Fantastic. Let's get going here. Let's do a little warm up here. I want you to find me what 5 square roots of 3 minus 5i to the 4th power is. Go for it. Hopefully by now you've seen the pattern. Okay? That if we got a number times the square root of 3 and the same number as your A and your B, you're just multiplying that number by 2 to get your R value. It's these relationships here that have been on the front board for a while. Okay? Then hopefully you've also already seen that when we're dealing with a number and the number times the square root of 3, that's either going to be 30 or 60 degrees for your reference angle. Okay? And it really depends on where the square root of 3 is. If the square root of 3 is on top, it's a 60 degree reference angle. If the square root of 3 is on the bottom, it's a 30 degree reference angle. So this is a 30 degree reference angle. Okay? Then you just have to adjust for which quadrant you're in. Positive, negative is quadrant 4. So actual theta is 360 degrees minus my reference angle. So in this case, actual theta is 330 degrees. Okay? Which would make then, so I take R to the 4th power. So that's going to be 10 to the 4th power. And then it's cosine I sine of 4 times 330 degrees. 10 to the 4th power is 1,000. Sorry, 10,000. Correct? 4 times 330 is 1320. Do I like 1,320 degrees for an angle? No. So we got to subtract off 360. Got to subtract off 360. Probably got to subtract off another 360, right? So it should end up being how much? What do you get? 240? Clear. 1320. $240, yes. Yeah, I knew that. Yeah, I knew that. Okay. And then if we wanted to put it in standard form, rectangular form, whichever one you want to call it, they both mean the same thing, then at 240 degrees, cosine is 1/2, so it would be 5,000 minus 5,000 I square roots of 3. We'll go with bad 5s, but I'm going to let it slide because I just do. Okay? Good to go on that one. Oh, yep, sorry. Yes, it would be negative 5,000 because we're in quadrant number 3. Yep. Correct. Good catch. How do you go from where? Top line, top round to bottom round? What's the cosine at 240 degrees? Negative 1/2. What's negative 1/2 times 10,000? Negative 5,000. Okay. Okay. Let's just do a little bit of simple algebra for us here right now. Okay. First one, 2x plus 3 equals 0. How do we go about solving that? Subtract 3 first. Gives me 2x equals negative 3. Then what? Divide by 2. Gives me x equals negative 3/2. Agree with me on that one? Yeah? Okay. All right, good. How'd you go about solving the next one? X squared equals 16. Square root both sides? Okay. What do you get for an answer? You get what? You get plus or minus 4. Right? Because when we're taking an even root and we're solving, we got to get the plus or the minus in there. Okay? All right. What about this number 3 down here? Factor? Is it factorable? No? Okay. So let's go crazy and let's complete the square. What would I fill in this gap right here? We're going to fill that one in with. What's our b value? 2. b divided by 2. If b is 2, what's b divided by 2? 1. What's 1 squared? 1. So I'm going to fill this in with 1. Well, what have I done? What have I done to my equation? I've unbalanced it, right? So to put it back into balance, what do I got to do? Add 1 to the other side. Okay. Then this factors to be that. Now what can I do? Square root both sides. I love how you guys are all looking at me like you've never seen this done before. Then what? Minus 1 or add 1? I've heard both. Minus 1. Okay. If you don't like completing the square, what's your other option there if it's not factorable? Quadratic formula. Okay, but then you got to remember the quadratic formula. Completing the square, so much easier. Okay. What are you going to do here? In number 4 first. Factor out an x. Then what are you going to do? Can you factor the middle? Two numbers that multiply together to be positive 2 and add to be negative 3. Then what?
The x outside becomes 0.
Set them all equal to 0, right? Right? Okay, what about here? Subtract 8. Yes? Okay, now let's talk math. Let's talk algebra. Let's go back up here to the top. How many answers were we supposed to get in the first one? 1. How many answers are we supposed to get in the second one? 2. How many answers are we supposed to get in the third one? 2. How many answers are we supposed to get in the fourth one? 3. And that's what we got all the way through, right? How do I know on a general algebraic equation how many answers I'm looking for in the end? Biggest power, we call, do anybody remember what we call that? Biggest exponent? Anybody remember? It's a D word. No? There were 98 of them in a boy band. It's also a deodorant degree. Okay? Okay? 98 degrees. Boy band. Okay? Degree. It's called the degree of the polynomial. Okay? Tells you how many solutions you're supposed to get. Here's why I bring that up. What's the problem with number 5? We only got one answer, right? How many do we need? We need 3. So we need 2 more. Okay? Now, let's talk about that one in itself. Okay? So we're here. We subtract 8, like we just did. That gets me x cubed equals negative 8. I have no idea what's underneath this shade. Oh, just that. Okay with that. Yes? Then what did we do? We took the cube root, right? Taking the cube root is the same as what? What's taking the same as taking the cube root? Taking it to the 1/3 power, right? Okay. So this is really negative 8 to the 1/3 power. Haven't taught you anything new yet, correct? Just kind of connecting different parts of algebra and algebra 2. Right? Okay. Now I'm going to connect those different parts to trig. So this is really would you agree with me on that statement? Yeah? Okay. What's the trig form of negative 8 plus 0i? Negative 8 plus 0i is what in trig form? What's my r value? 8. What's my theta value? 1/8, because it's going straight out to the left, right? Okay. So this is really 8. Oops, I don't need the parentheses. CIS of 180 degrees. Yes? So if those two are interchangeable, then I can say here that x is equal to 8 CIS of 180 degrees to the 1/3 power. Can I say that? Yeah, okay. Now what can we do? Can I apply de Moivre now? Trig, a complex number in trig form to a power? I can apply de Moivre, right? Okay, so this is going to be eight to the 1/3 power, correct? CIS of 1/3 times 180 degrees. Yes? What is 8 to the 1/3 power? It's 2. What is 1/3 times 180 degrees? 60 degrees, right? Yeah. So that is my first root. Right? Which, if I put that into standard form, that's going to be 1 plus I square roots of 3. Do you agree with me on that? Cosine of 60 degrees is positive 1/2. Sine of 60 degrees is positive root 3 over 2. 1/2 times 2 is 1. Root 3 over 2 times 2 is root 3. Okay? If we were graphing these, we would have our first root would be right there, correct? because it would be 60 degrees to there. Yes? What did we come up with for the first time that we did this problem? We came up with -2, right? -2 would be right over here. In trig form, it would be 2 CIS of 180 degrees or it would look like that, or just be -2, correct? Okay. Well, what kind of a gap is here? But we know exactly what it is. We don't need to know that it's obtuse. What kind of a gap is it? How big? 120, right? So does it make sense for us to then have a 60-degree gap here and a 120-degree gap there? Does that make sense? Because what does that actually produce? Produces 3 120-degree angles, right? Which are equal, which would divide the circle into thirds, yes? Okay, so if I add 120 degrees more, where is x sub 3? What is my angle? I know my radius is going to be 2, but what is going to be my angle? It'd be what? It'd be 300. Which, if I do that, 1/2 times 2 is 1. 1/2 times -√3 over 2 is -I square roots of 3. Yeah. Now, if I go back to this, so there's my original problem, yes? That is actually factorable. It's a cube plus a cube, so this would be x plus 2 times x squared minus 4x plus 4. No, correction, minus 2x. Not 4x, minus 2x plus 4. And what you learned back in Algebra 2 was that this one you can set equal to 0. This one you can set it equal to 0, but this trinomial is not factorable. So you'd have to go through and you'd either have to complete the square or quadratic formula. Okay? And when you do that, you would get x equals 1 plus or minus I square root of 3. And there's your 3 roots. Okay? So let's come up with a simplified plan for all of this. Okay? If I've got x cubed equals 27, how many answers do I need to get? 3. But if I just take the cube root of both sides, I only get 1. So I got to come up with the other 2. Okay? So our first step is we are going to trig it. Okay? You're going to take your number and you're going to transform it into trig. Okay? So this would become x cubed equals 27 CIS of 0 degrees. Because 27 is out here at 27, 0. If we go on the complex plane, okay, it would be 27 plus 0i would be 27. Do we all agree with that? Okay. So we trig it, and then after we trig it, we root it. Okay? So we trig it and we root it. Which means then that this is going to be, I'm going to take this to the third root, which means I'm going to take this to the 1/3 power. Those mean the exact same thing. So then I get x equals 27 CIS of 0 degrees to the 1/3 power. Then we demov it. Twenty-seven to the 1/3 power is 3. One third times 0 is 0. So that's our first one. Yes? Right? Here's the tricky part. You got to do a little bit of math. Okay? So now what you're going to do is you're going to take 360 degrees and you're going to divide it by the degree of your polynomial. So what was our degree in this one? What was our degree? Not our angle. What is the degree of the polynomial? 3. It's the biggest power, remember. Okay? Not the degree of the angle. No, 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 no. Degree of the polynomial is different. So it's 3. So what's 360 divided by 3? How much? 120 degrees. So my next root then is going to be 3 CIS of 120 degrees. My next root is going to be 3 CIS of 240 degrees. I can't go any further because if I add 120 degrees to 240, what do I get? 360, which is right back to the first one. And I've got my 3 roots. Okay? Now you just got to convert them. So 120 degrees is negative 1/2. So that's going to be negative 3/2. And then that's going to be plus 3I square roots of 3 all over 2. And the last one at 240, it's going to be negative 3 over 2 minus 3I square roots of 3 over 2. Okay? Let's get cray-cray. Because it's literally 3 steps. What was the first step that we got to do? We got to trig it, right? Okay? So what is 3 plus I in trig form? Three plus I in trig form. It's got a square root of 3 in it, right? So what's my R value? What's my R value? 2. Right? Because it's 1 square root of 3 plus 1I. So 1 is the number. 1 times 2 is 2. So this is 2 CIS of But if you want to do it that long way, have fun. Go ahead. You can always do it that way. A squared plus B squared square root. Okay? I just see the pattern. Okay? What's my degree? Not of the polynomial, of the angle. Is it 30 or is it 60? Is it 30 or is it 60? It's 30. Guys, if you don't know, you can fall back on what we were doing last week. You can always inverse tangent it. But by now, you should be smart enough to see these patterns and make your life easier. Okay? This has been on the board for almost a week now. But it will not be on the board next week. Okay? So now what do we do? After we trig it, we root it. So I'm taking the 5th root on the left side, and I'm taking the right side to what power? 1/5. Okay? De Moivre says what? That's step 2. De Moivre. What does old Rene De Moivre say? Two to what power? The 1/5 power. Cosine I sine of 1/5 times 30. How many answers do I need to have? I need 5 answers. My first one is going to be what? Fifth root of 2 times cosine I sine of 6 degrees, right? That's my first one. I won't make you find the standard form for that one. Okay, we can leave it just like that. How many roots do we have? There's 5 of them, right? So what's 360 divided by 5? So that means I've got to add 72 to the angle measure, yes? Okay, so my next one then is at the 5th root of 2, CIS of 78 degrees. Next one is at the 5th root, 5th root, that's bad 5. 5th root of 2, CIS of 150. Next one is at 222. Next one is at 294. And if I added 72 to 294, what would I get? 366, which I don't like, so I subtract 360, and I'm back to 6 degrees. And there's your 5 answers. And you can leave it just like that. Yep. We actually prefer it because it's exact. Okay? You try that one. $66. Okay. I think that's right. 66 plus 72 is 138. Plus 72 is 210. Plus 72 is 282. Plus 72 is 4. Carrying the iron. Yep, 354. Yes. Questions, comments, concerns, clarifications? Trig it, root it, all in one. Mov it, solve it. Really, after today now, after learning roots now, you can finish off the rest of the packet. Okay? Now, I am fully aware that as you get going into that packet, and as you get into some of these powers and some of these, multiplication problems, that how do I want to say it? The numbers get rather ginormous. Okay, so you might not be able to fit your complete answer on the teeny tiny answer blanks that was the first draft of the homework packet, which also made it into the homework packet that you have. So you might have to go above the line to write up some real answers, because you'll get some answers in the millions. 7.